Hey, what's going on, folks? It's Mike here, and welcome to the C in a Day lesson, and welcome to your 9th day in the C programming language. Now, this lesson is going to be a little bit strange compared to the other lessons in that I'm actually not going to be doing any live coding, but we're instead going to be doing a code walk. So a code walk is something that you might do in industry where you're reviewing some code, presenting some code, or just trying to check the validity of some piece of code. But in this instance, it's just going to be a little bit of a tutorial of how to do some things in the C programming language that we haven't really focused on yet in this series. And in this lesson, I'm going to be showing you or contrasting C code versus code in the C++ programming language. And specifically, I'm going to be talking about object-oriented programming. So C by default is not an object-oriented language, meaning it doesn't have things like methods, member functions, and so on built into the language. That said, you can implement these features from scratch because, well, C is just a programming language like any other language. So with that said, I hope you can sit back and just appreciate some of the cool things that you can do in C, and hopefully you'll learn a little bit of something and get excited about maybe trying to implement some of these features, or otherwise just better understand how these features might be implemented in other languages. So let's go ahead and dive into it. So what I've got here is a data structure called array. And I'm going to make it a little bit bigger here just so you can see the code on the screen. And you're going to notice that the bulk of this code here today is basically just this data structure here, array, that we've created as a type def. So recall that a struct is just a way for us to aggregate a bunch of different data types together to form some other new data type. Now, this is going to be a little bit unfamiliar in some of the things this time that I've included in the struct that maybe you haven't seen before in previous lessons. So there are some familiar things like size and data. Those would be the two minimum things that we have if we wanted to create some sort of array type, for instance, in the C programming language. The data would be the underlying integers that we are wrapping this data structure around and holding the actual contents, and the size is how many elements have been added to this array. All right, so what are these other things here? Well, there's something here called self, which is just going to be a pointer back to the array itself, so it can kind of keep track of itself. Again, that's a little bit weird, but I'll talk about that or show the corollary in C++. And then I have some function pointers, which we have recently learned about here. Now, while these wouldn't be strictly required, they could be useful for various reasons if you go on to do some object-oriented programming. And the idea is that we would have functions to set various pieces of data at some index and also retrieve or get various data at a particular index here. Okay, so let's go ahead and look at some of those functions, and then we'll start putting things together. And I'll revisit this section so we can talk about why I've structured this C code as I have. Now, as I go down here, you'll see some functions here specifically related to the array data structure, or the array underscore t, that's our custom defined type here, and the getter function here that I have listed. And what you're going to notice here for these member functions is that I'm always passing in the actual array first as a pointer here, because, well, we have to figure out what array we're actually working with, and then the actual index of the data that I want to retrieve. And then you can see that we retrieve self, data, and the actual index here. Now, it might also be worth noting for these data structures that you build in C, it might be worth doing things like, for instance, checking if the index is greater than self size, then maybe we just return an error code, an error message, or do something here. But I've omitted that error code for simplicity for now, because you'll have to make a decision as to what it means to have a index that is greater. Oftentimes folks will use assertions, for example, which we learned way back in the first day in C how to use. Okay, so that's the sort of get function that you might have or want for your array. And then, of course, you would have the set function as well. And you can see in this one, I have included a little bit of error checking here, meaning that, well, if the array itself is null, then, well, we might want to just return in this case. Otherwise, we do a little bit of error checking here to check the size, and then we can update the actual value at a particular index for whatever the array object is that we're passing in. Okay, so this much should look familiar. This idea of having a function here where we can pass in some type and then manipulate some of the underlying data structures in our actual array here. Now I'm going to go ahead and move on to two of the other functions here, which are maybe less familiar from things that we've done before in this series, but would be common in any other language, as well as once you start building your data structures in the C language. For example, you would want the ability to make or create one of these array T data structures. And typically we can do this with some sort of, and folks might call this a factory function, that is a function that creates objects, where we make an array with particular capacity. That would eventually set, well, for our array, once we allocate memory for it, we would set the size of that array. How big can that array be? Now, and then eventually, once we've done that, we would return the new array here. So this much should look relatively familiar at this point if you've been following along with the series. Lines 40, for instance, lines 44, where we're setting the capacity of our array, updating one of the fields of our structure, and then eventually returning that array. Now, the things that are going to look a little bit strange here is that I'm setting this self pointer here, which if you allow me to just split our screen here for a moment, and I'll go ahead and put the structure here at the top here. Recall that our actual array has this pointer back to itself here. And the reason for this is that oftentimes we might want to keep track of our actual object that we have here. So let me go ahead and get us back to the line here. So the actual array that I've allocated, I'm just going to keep track of where that has been allocated. This isn't necessary, but it shows the idea if you've done any Python programming and seen this variable self, or perhaps in C++ and Java where you've seen this value, which essentially is just a pointer to the object itself. Okay, so just hold on to that idea and we'll see it in the other programming language, C++, which we're going to review in this video. Okay, so that's the idea. Now, the other thing that I'm doing in this make array function is that I'm setting my function pointers here. So I have these variables here, pfn set, and p is a prefix for pointer, fn is a abbreviation for function, and the set function that I'd like to use here. Okay, so that is these actual function pointers here. Now, recall that these names are actually a little bit simpler than the actual functions that we saw in the code. So if I go ahead and scroll down here, you'll see that we call this get underscore array underscore t, but instead our get function, we just want to refer to it by this simpler name. In fact, it might even be better if I just call this get and get rid of this sort of strange prefix. But again, I want to show you that strange prefix, the pfn, because you're going to see that in other code bases every once in a while, so you should just be aware. All right, so I'm actually setting up how this particular array underscore t function is going to get or set variables. So for instance, I could set it to another function that looks similar to retrieving data, but maybe this time I want to set that to a function that indeed does do the bounds checking. That is, it checks that the index is a positive number and it's less than size, and that the array has itself been allocated and self is not a null pointer. So I do have some options in how I can construct this actual struct by using these function pointers. And this is getting to some of the object-oriented programming techniques such as polymorphism and constructors that you may have seen in other languages. And if you haven't, those are just some words to keep in mind that are of importance when programming and object-oriented programming. Okay, so now that we've looked a little bit at this constructor, maybe understand why I'm setting things up a little bit different, let's look at the final function here I have here, which is an array destructor. And this is simply called destroy array, which is going to free the actual array that we have allocated. So first we're taking care of the data and then freeing the actual array itself. Now remember, whenever we do this, so let's go ahead and look at our array here, we do have to be careful in the order that we delete things. If I was, for instance, to free the array itself before the data, well, I would lose any notion or any way to get back to the data that's stored inside the structure. So the order here definitely matters, and this is often something that we'll want to do in our C code to ensure that we make it very easy for the user to delete their code. Now, this idea of a destructor, a destroy, or a dispose function in other programming languages has become so popular that it's often built into programming languages. So again, in Java, C++, there is some ability to destroy objects. And in C++, which we're going to look at, you explicitly write this function. Other languages like Java and so on will create this destructor for you and take care of freeing the memory, which is very nice and an evolution in programming. Okay, so this is the code that we have here. And let's go ahead and just see a use case of creating this array object here, which I'm going to do. And it'll have 10 elements. I'll set all the elements. Again, I'm going through my function pointer and not using this sort of raw call up here where I'm setting the data, because this provides a little bit of a cleaner interface. Now, this is going to be a little bit strange here in that I'm sending in test and then retrieving self. In fact, just in case you're wondering, I could just pass in test itself and that would be fine. But I'm trying to demonstrate how object-oriented programming languages may have implemented some of these things from scratch. So this is ideally something that you could do. Again, maybe not the most performant code, but this is what's going on. We're saying, what object am I? So that we make sure we're working on this test array, which we just created. And that's one where I'm setting at a particular index, a particular value. Okay, so that's the first part here. And then what I'm going to do is then just loop through all of my values here and just retrieve the size, each of the actual values at index I. Now we could probably improve this code just a little bit here. So again, I could just do test size just to make sure that we go through each of the values here. And let's just go ahead and make that small change just to clean our code up. All right, so now that we understand the code a little bit, let's see it in action, make sure that it actually runs, and this is valid code. So I'll run GCC, I'll compile with debugging symbols, and the file that we're compiling main.c, and output as prog here. And just so you can see it on one line, here is the code. And I'll go ahead and run it, and you can see it's a pretty simple printout of our data structure here, 0 through 9. Okay, so that's the idea with this particular code here. So let me go ahead and scroll through it one more time, slowly reviewing what we've done, and then we're going to see this same code in another language so you can see how a C++ programmer might implement this. Okay, so again, here is our struct array. I've made it a type def so that I can just call an array underscore t. Here's the actual important stuff in our array, the data, where our array is, the size of the data structure, and then some object-oriented things that I'm adding in here that aren't really necessary in C, but are going to help us when you go on to learn C++ or another language, is this idea that we're able to have a pointer to ourselves, so we can refer to ourselves, and this idea of having member functions implemented as function pointers where I can point to the correct function for how do I set data in this data structure, or how do I get data from this data structure. And I could, of course, add as many other member functions as I want, things like retrieving the size, or perhaps iterating and printing out the array, or whatever else you would want to do. But here's two for demonstration. Okay, so here is the actual functions that do the work here for our data structure. But again, I've used these function pointers because they're also a little bit nicer to just call with this simpler syntax here. pfn set and pfn get for pointer to a function get and pointer a function set. Okay, and then I introduced this idea of a constructor. Here is the make array function, which returns an array t, a pointer to one that has been allocated on the heap here, which again, this should look familiar. And then I have appropriately destroyed our array. Okay, so that's the C code here. Now, let me go ahead and show you what would be the equivalent C++ code. And I'm expecting most folks who are watching this series have not seen C++, but if you've seen the associated C code on the left side of the screen here, you should be able to get enough of an idea of what it looks like in C++. So I've written a main CPP And disclaimer for both of these files here, I've just written everything in one file for simplicity, so you can get the idea. Okay, so let's go ahead and look at the array T structure, but on the C++ side. So that's on the right side, which I am highlighting on the screen here for how this is implemented. So I have a struct like in C, but it works a little bit different in that I can have my member variables here, which are publicly available. These are the fields of our struct, and those look exactly the same. But this time I have explicitly a constructor here. And you'll notice what's a little bit different about this constructor is, well, let's go ahead and actually compare it to our C file here. So again, I'm looking at this constructor at line 7 here. And let me go ahead here to our make array is, well, there's no return value. So in C++, because I've declared and defined this function, which is part of our struct here. And again, there's different ways to do this in C++. You can check out my series for that. But the idea is I don't have to return anything. We know it's part of this array structure, so we're just inherently building something that's working with this data, this size, and so on. In fact, you're not going to notice a self pointer anywhere because in C++ we don't require it, but we could just use this here to explicitly talk about the data that we are creating here. Okay, so instead of having this self pointer, which I was referring to earlier. Okay, so that's the idea of the constructor. And then you're going to see another function here, which is named the same as the type here. So I have an array here, and an array with the little tilde mark here, which I'm highlighting at line 13. And this is the destructor. So this is the object that's the function that's automatically called on this object when this object goes out of scope or is explicitly deleted in C++. So what are we going to do? Well, we just delete the data that we have allocated. And we allocate data with new in C++, which is the equivalent of malloc. And delete would be the equivalent of freeing. If we're freeing an array, we have the brackets here. And you'll notice that I don't have to explicitly do anything like, say, delete this object, because that's automatically going to happen with the destructor. So already fewer things that I have to worry about in C++, which is nice, versus, again, our destructor, where we had to free the data and remember to free the actual structure itself. Okay, so if we continue on, let's go ahead and see the set function and the get function. Now, again, these are not complicated functions, and I've omitted any sort of error handling. But what you're going to see here, if I show, for example, the equivalent on the left side of the C code for our get function, we do the array that we are operating on, but implicitly we are just working or operating on whatever this object is. We don't have to pass the array itself or any sort of self pointer. So you're just going to notice 2 arguments here for the setter versus 3 here, and for the getter, 1 argument here versus having the 2 arguments in our C code. Okay, so it's a little bit different. And then the actual structure of our code here, we will create or allocate. Again, in C++, we use new, our array with 10 objects, set everything, and just get everything. So let's go ahead and briefly compare that to our C code here, which again, at this point is about the same amount of code. The big difference being that we're just able to operate directly on this object, because in C++, we're able to create actual objects here, which have functions which we call member functions that directly operate on this object. So this would be the equivalent in C as what we are doing in C++. So let's go ahead and just compile this code here, because you might be following along and just want to see how it works. So we need a C++ compiler, G++, or Clang++, and we can compile it almost the same way, and we get basically the same output here. So 2 different programs in 2 different languages doing the same thing. But again, the value in this lesson is what I'm trying to show you. In C, we can program in this sort of object-oriented way, and understanding how objects might be constructed from scratch can be valuable, or at least appreciated, in languages like C++. So for instance, we could do different things in C++, like inherit, or change the behavior of these set or get functions. And in the C programming language, we would effectively be changing what these member function pointers are, but have to manually do that if we want to change behavior. And in object-oriented languages, there's other mechanisms for doing this. So folks, with that said, this has been a lesson that I've wanted to do for a while because I very much enjoy C++ and C, and it's interesting to try to see how these language mechanisms work by implementing them from scratch in a way, or a subset of how these features might be built. In fact, if you don't know the full history of how C++ came, there was previously a compiler known as C++ Front, and it basically took C code that was generated and would generate the sort of C++ version of it using some of these tricks and generating code like in the C++ case where we have member functions and member variables all tied together neatly in this struct type. So it might be interesting for folks who really do a deep dive into the C language to figure out how to implement other paradigms and other things that are a little bit more normal in other languages. Things like polymorphism, things like templates or generic programming, and other things like inheritance. So all of these things are generally associated with object-oriented programming. So again, knowing that information, though, you can program in an object-oriented style in C. And again, usually learning a few programming languages will benefit how you work in either language. So that's the lesson for today. We'll get back into C programming later on, but I think this would be a lesson that would be interesting for folks to look at and think about on their C programming journey. So thanks for your time, folks. Make sure you like and subscribe so you don't miss the next lesson where we dive back into some C code, and we'll see you soon.